Hi again. So this is my video on how to find derivatives of trig functions. So as part of your trigonometry, you would have done functions like sine, cosine, tangent, cotangent, secant, and then cosecant. And then so now we will actually try to find their derivatives. I mean, their rates of change. For example, you know that most waves that you see in nature are trig functions. So if you want to find the velocity of a wave, right, or a vibration of some sorts, right, okay, yeah, and then you will need to how to find the derivative. So let's go back to the basics and see, so what's going on. So if we have a function like this, right? So how far do we know how to find the derivative? So far we have done power rule, so we can take care of this, right? And then we know the constant multiple, we can take care of that. And we know the sum rule, so we can take care of sum, but we don't know how to find the derivative of sin x. If we knew that, we could have taken care of this whole thing. And because we know product rule, we could have taken care of the entire top part if we knew the derivative of tangent x, right? Okay, and then we will know the entire top part. Because we know quotient rule, we could take care of the bottom, the whole thing, only if you knew the derivative of cosine x. So when you do an expression like this, in addition to the power rule, the constant multiple rule, the sum rule, the product rule, the quotient rule, we will also need to know the derivatives of trig functions. And then so I will put elsewhere the proofs of this. There's some beautiful proofs, but this is not the time and the place to do the proofs. So I will just tell you what the derivatives are right up. But if you want to look it up again, if you look at near my video on the course management site, I will put some videos where you can actually show how these derivatives come about. Okay, so the two most important derivatives here are, first of all, the derivative of sine x is very beautiful. It's really cosine x. It's one of those nice things about nature, provided that the x is actually measured in radians. So if you ever wondered about the big deal about degree and radian measures, one of the places where the radian measure is absolutely a must is in calculus. So the angle has to be measured in radians. And because in the proof of this, using the limit definition, there comes a place, there's a certain limit which is true only if the angle is measured in radians. Okay, so that's why these proofs are beautiful. If you have the time, you can go through it. Okay, so first is the derivative of sine x is cosine x, and the other one is the derivative of cosine is actually negative sine x. So sine and cosine are basically the foundations for all trig functions. And if you know those, you can actually find the others. So for example, if you want to find the derivative of tangent x, right? You can show that the derivative of that is secant squared x. And how do you get that? Because we know that tangent x is sine x over cosine x. But we know the derivative of sine x and we know the derivative of cosine x, right? Okay. So if you just use the quotient rule for that, right, you get the answer, right? So if you want to differentiate sine x or cosine x, what you do is you do the low d high minus high d low all over low squared. So low d high, the low is cosine x, derivative cosine x, derivative of sine x, the d high is the derivative of sine x, which is again cosine x, minus high d low, minus high is sine x, derivative the d low, which is the derivative of cosine x, which is negative sine x, right? Okay, and all over low squared. So low squared is cosine squared x, so all over cosine squared x. So this is cosine x is cosine squared x, right? Plus sine x is sine squared x. So cosine squared x plus sine squared is, which is actually equal to 1. So 1 over cosine squared x, right, which is actually secant squared x. Okay, because 1 over cosine x is secant x, so 1 over cosine squared is actually secant squared x. So likewise, we can show some others, right? I mean, for example, we can show that the derivative of secant x is um, this is not correct, so it's actually secant x. Secant x tangent x, right? And the derivative of cosecant x is cosecant x and cotangent x, right? Okay, and then the derivative of and there's a negative here, right? Okay, I think and the derivative of cotangent x is negative cosecant squared x, right? So so how do you get this? For example, I'm not going to do this, but 1 secant x is 1 over cosine x, right? So 1 over cosine x, right? Okay, so if you want to take that, right? Okay, so it will be the same as the derivative of 1 over cosine x, and then because it's a fraction, you can use quotient rule, and if you use quotient rule, you get that. Likewise, what is cosecant x? Cosecant is 1 over sine x. So if you use the quotient rule for 1 over sine x, you will get this. Likewise, what is cotangent x? That is cosine x over sine x. Once again, you can use the quotient rule for cosine x over tangent x, and you will get this after using the quotient rule. But you need to memorize all these basic things when you're preparing for the exams, right? Okay, so what are the basic things? The derivative of sine x is cosine x, the derivative of cosine x is negative sine x, and the derivative of tangent x is secant squared x, right? Okay, and and things like that, right? Okay. So in addition to the sine, cosine, and tangent derivatives, you also need to know the derivative of secant x, which is secant x tangent x, derivative of cosecant x, which is negative cosecant x cotangent x, and the derivative of cotangent. So you must know this by heart. There's no way out because these are the first 6 trig functions and you should know the derivatives. Let's do an example right quick. So if you have y equals x sine x plus 2 tangent x, how do you find the derivative of that? Well, first of all, it's a sum. So if you can find the derivative between these two pieces, right, then you're done. So first find the derivative of this piece. So this piece itself is a product, right? So you can use right one, derivative of 2, derivative of sine x, there it comes, so that will be cosine x, plus right 2, which is sine x, plus the derivative of 1, which is 1, okay, so plus uh, the derivative of 2 tangent x, which is what, 2 secant squared x, okay, so that's the derivative of this part here. And so we have a y equals cosine t over sine t plus 1, which is the quotient, right? Okay. Find the derivative, then you do low d high sine t plus 1 times d derivative of high, which is negative sine t, minus high cosine t, the derivative of sine t plus 1, which is cosine t, and all over low squared, which is sine t plus 1 squared. Okay, so low d high, the derivative of cosine t is negative sine t, minus high, which is cosine t, times the derivative of this. So the derivative of this is the derivative of sine t is cosine t, derivative of plus 1 is 0, so again cosine t. So you can simplify this a little bit, right? Because if you distribute this, you get negative sine squared t, negative sine t is negative sine squared t, and then minus sine t, and negative cosine squared, cosine 2 is negative cosine squared t. So negative sine squared t, and if you take the negative out, you get negative sine squared t plus cosine squared t. So negative sine squared t and negative cosine squared t. If you take the negative out, you get sine squared t plus cosine squared t, and then you get a negative sine t from here, negative sine t divided by 1 plus sine t squared. Okay. Now we know that by Pythagorean that sine squared t plus cosine squared t is 1. Okay, that's a Pythagorean, first Pythagorean, right? And that goes negative 1 here, negative sine t, and divided by 1 plus sine t squared, right? Okay, and then you can actually take out a negative 1 from here, and then if you take a negative sign from here, you get actually you can factor out a negative sign from the top, and you get 1 plus sine t. And that will further cancel out because you will get a. So now you can see there's a common 1 plus sine t over 1 plus sine t squared. So one of the 1 plus sine t's will cancel out, and your final answer will be negative 1 divided by 1 plus sine t. So once again, 1 plus y sine t is common to both, so one of them will cancel off, and that's your answer. So that's it for this video, right? Okay, and we will meet you. So today's topic was to find the derivatives of the six trigonometric functions: sine, cosine, tangent, and then secant, cosecant, and cotangent. Okay. All right. Thank you for watching.